So welcome back again. In this video I'm going to be going over the standard form of the quadratic equation. So the standard form of the quadratic equation, when you saw me write it out earlier, it is y equals ax squared plus bx plus c. And the only limitation on a, b, and c is that a cannot be equal to 0. So in the standard form of the equation, we can get out information from a and b, specifically information about whether it opens up or opens down, its width, where its vertex, and where its axis of symmetry are. To get started, A is going to tell us whether the parabola opens up or opens down. So, if it opens up, this implies that A is positive. If it opens down, this implies that A is negative. If you see me writing this, you might see me just use the plus sign or the minus sign in parentheses to connotate positive or negative. That's my shorthand. So, to see an example of this, we've got a graph. We've got a parabola with an A that's positive. It opens up. If we have an A that is negative, my graph is going to open down. And that's what we mean by this. So, a couple of other things to note. If the parabola opens up, the vertex is its lowest point, as we see down here. If the parabola opens down, the vertex actually becomes the highest point now. The other thing we can get is information about the parabola's width. For this, we need to compare it to something. So we're going to compare to the parent function, y equals, so we got our graph, and let's say this is y equals x squared. I'm going to consider two additional functions. First, I'm going to start out in the most general terms. I'm going to be comparing the following situations. In this first case, I'm going to have a situation where the absolute value of a is going to be greater than 1. So in this case, I'll show you two possible examples. I could have, for instance, y equals 2x squared, the absolute value of 2. So this is my a out in front. My a is always the coefficient in front of x squared. A is always going to be the coefficient in front of x squared, every time, when we're talking about these cases. Another possible example that will give me an absolute value of a that's greater than 1 is, say, y equals negative 3 x squared. If I took the absolute value of negative 3, that equals 3, and 3 is greater than 1. So, keep that in mind. We're looking at the absolute value of a compared to 1. So, if the absolute value of a is greater than 1, let's consider a case. I'm going to do two things. In this case, I'm going to consider x and y. In this first case, where y equals x squared. And in my second case, I'm going to consider x and y. But this time, I'm going to say y equals 2x squared. So again, my absolute value of a greater than 1. So, in the first case, let me do 0, negative 1, 1, negative 2, 2. 5 values. If I put in 0 for x, I'm going to get out 0. Negative 1 will give me 1. putting in -1 for x squared will give me 1. You can check this out in your calculator if you're not 100% certain of your skills in doing squaring in your head. Now to go to the next case, I'm going to use the same set of x values, 0, -1, 1, -2, and 2. But now I've got this little extra bit that I have to consider. When I put in this x value here, I've also got to multiply it by 2. 2 times -1 squared, though, is going to give me 2. So it's going to look like this, for those who want a visual. 1 will give me out 2, and then if I use -2, I'll actually get out 8. So if you look at these two sets of numbers here, you notice this set of numbers is growing faster. So now, if I were to use this and compare it to here, what would actually happen is this graph of y equals 2x squared grows much faster and is much skinnier. So when we have an absolute value of a that's greater than 1, we'll have a skinny parabola because it goes faster. And you can look at the picture and at the numbers to help you see that. So let's consider our next situation. In this case, we're going to have a with an absolute value that is less than 1. So this can occur in a couple ways. If we have a fraction that's less than 1, so for instance, 2/3 is less than 1, or 7/9, or -5/11. These are all instances of fractions that are less than 1 or -1. These will help us satisfy this situation. We may also see a written as a decimal point less than 1. So for instance, we might see 0.14, or we might see -0.76, or 0.999. All these cases would give me a situation that would make this statement true. Parabolas with an absolute value of less than 1 will result in a wider graph. So let's go back and consider our parent graph of y equals x squared. And let's make our comparison graph be y equals 0.5 x squared. In this case, I'm going to do again the two tables so we can see it in the numbers. So starting with this second one, I'm going to do 0, 1, -1, 2, -2. And we've seen these numbers before. They're like from the last problem that I showed you. In this case, I'm going to use those same x values, 0, 1, -1, 2, -2. But when I do this, I'm going to also have to multiply. Just caught a mistake. There we go. I'm also going to have to multiply by 0.5. So 0 times anything is still going to be 0. If I plug this into my calculator, I'll get 0.5 out. And same thing here. And if I do this with 2, I'll get 2 and 2 out. So if I were to plot this out on my graph, it would look like that. Much wider than the original one that I'm comparing it to. So what ends up happening is our graph is wider because our output numbers, the values that we're getting for y, are growing at a slower rate than our original parabola. One other thing to note, these considerations for a will be the same no matter which form the equation is in, whether it's standard, vertex, or intercept. So to summarize, a positive a implies open up. A negative a implies open down. An absolute value of a that equals 1 implies same width as y equals x squared. Situation where the absolute value of a is greater than 1 implies skinny graph. And the last case, a is less than 1, implies a wide graph. So, use this. I'm going to retitle this one because it took a little bit longer. And instead of the standard form of the quadratic equation here, we're considering the effects of the... So, we're now going to call this video the effects of the coefficient a on a parabola. Join me in our next video where I really do get into the standard form.